All right, so we're going to talk a little bit about the next type of chemical reactions. We've already looked at synthesis, we've already looked at decomposition. The next one up is single displacement. Remember, we still have two more after that. Okay? Single displacement, characterized by this general form. A, meaning a single element, plus BC, a compound, goes to B plus AC. And if you look real carefully, you'll see that A and B have switched places. That's the single displacement that we're talking about. The general description of the reaction is that a more reactive element will replace a similar, less reactive element in a compound. Okay? The reactants for single displacement reactions are typically an element, usually it's a metal or a halogen, fluorine, chlorine, bromine, or iodine, and a compound, which is usually an ionic compound, and that compound is almost always in solution. Okay? So that's how you can identify a single displacement reaction. The products are a new element and a new compound. And again, that compound is usually in solution when it forms. So that's how you can recognize, another way to recognize a single displacement reaction is by looking at the products. When you do these, don't get thrown off by what's in the reactants. Write the products, write their formulas according to the rules you already know. Okay? And then balance as usual. So here are some examples. I want you to pause the video and write these down, leave some space underneath so that we can write the equations for them. We have a piece of calcium metal added to a solution of lead-2 nitrate. We have some powdered iron dropped into a solution of silver chloride, and we have lithium metal put into water. So pause the video and go ahead and jot those down, and again, leave some space so we can write our equations. All right, so let's take a look at the first one. We have calcium metal in a solution of lead-2 nitrate. I'm going to write the formulas for my reactants pretty quick. You should be able to write formulas by now. Okay? So if you're not sure, go back and watch the videos on how to write formulas for ionic compounds or whatever. So calcium is Ca, and it's a metal, so it's solid. Lead-2 nitrate is Pb parentheses NO3 parentheses 2, and that is a solution according to our problem. Okay? Single displacement reaction means that the calcium is going to replace the lead. Okay? It's going to kick the lead out of this compound. The lead is going to come out by itself, lead metal, which is solid. And the calcium is now going to go into a compound and take up the nitrate and become calcium nitrate, NO3, 2, and that is aqueous. Okay? Now it happens that this reaction is already balanced the way I've written it. One calcium, one lead, and 2 nitrates on both sides. It won't always be that way. But notice that I've written my formulas the way that I know how to write formulas. Okay? So, a single displacement reaction, the element will replace a similar element to itself. Both of these are metals. That's how they're similar. Now, there is something about being more reactive, less reactive. We'll talk about that later, but that's basically how you do it. Okay? Let's take a look at the next example. We have iron metal in a solution of silver nitrate. So iron metal is just Fe, solid. Silver nitrate, Ag plus 1, nitrate minus 1, AgNO3, and that is a solution, aqueous. Okay? Single displacement means the iron is going to replace the silver. It's going to kick silver out of this. Silver will become just silver metal. And iron will go into the compound with nitrate. But iron likes to be plus 3. So we're going to give iron the plus 3 charge that it prefers. That means I have to write this FeNO3, 3, and that is a solution, aqueous. Now I have 3 nitrates here, but I only have 1 nitrate on this side. So I'm going to put a 3 in front of the AgNO3, and I'm going to put a 3 in front of the Ag to balance out my silvers. And there's my balanced chemical equation for this single displacement reaction. Okay, we have one more. We have lithium reacting with water. Now here's where things get interesting. Water is not an ionic compound. But for the purposes of doing this, we can kind of pretend it is. Lithium is just lithium. We can write that down. Lithium solid, okay? Now, water we'd normally write as H2O, right? And it's a liquid. But I find that for single displacement reactions and double displacement reactions, sometimes it's more useful to think of water instead of as H2O as HOH, liquid. It's essentially the same thing, 2 hydrogens and an oxygen. Where this becomes useful is that it shows me that water is sort of like a hydrogen ion, and a hydroxide ion. And I can treat it that way. The lithium is going to replace just this hydrogen. Now hydrogen is going to come out of this reaction. And hydrogen, when it's by itself, is always 2. That's hydrogen gas. The lithium now is going to be in a compound with the rest of this molecule, the hydroxide ion, OH minus, LiOH. This is an ionic compound because it contains the metal lithium. Because there is water involved in my reaction, and because lithium is an alkali metal, this will be aqueous. All alkali metal compounds are soluble in water, always. Okay? So that's going to be aqueous. If there were no water involved, then it would be solid, because ionic compounds are solid at room temperature if there's no water around. Now, this is not balanced. I need to go ahead and balance this. But I have one hydroxide here, one hydroxide here. I have one lithium here, one lithium here. I have 2 hydrogens here, but only 1 here. So I'm going to put a 2 in front of the HOH. That gives me 2 hydrogens. There they are. That also gives me 2 hydroxides, which I only have 1 here. So I need to put a 2 there to get my 2 hydroxides, and I need to put a 2 in front of the lithium to get my 2 lithiums. Okay? So when using water, now water only reacts with certain kinds of metals, the alkali metals specifically, and some of the alkaline earth metals. But if you see the reaction of a metal with water, try writing water as HOH instead of H2O, and treat it as just an H plus ion and an OH minus ion. It makes for very easy single displacement reactions. Remember, the metal will only replace the first hydrogen, the one out in front. But when it comes out, when this hydrogen comes out, it comes out as H2, because hydrogen H2 is diatomic. And that's really important that you remember that. Okay? It's going to take you a little bit of practice to get used to doing this. Really, the ones with water are the tricky ones. There's sometimes ones with acid, but we'll work on it, and hopefully you'll pick it up pretty quick.